All right.
Okay.
Yeah, another minute to start. I think people are ready to get started, huh? 3 o'clock? I got 3 o'clock. Let's go ahead and get started. So, welcome everyone. I'm John Caracas, one of the research faculty here in the center, in case you don't know me. And I have the privilege of introducing our guest speaker today, John Fisher from Brandywine Photonics. And just a few words about John. I've known him for a number of years, having met him at conferences along the way. And I always found that he had an interesting perspective to bring on discussions. If any of you are on LinkedIn, I would encourage you to follow him. John's a pretty active poster on LinkedIn, and he comments on happenings in space business, Earth observation, and a variety of fields. And I find his comments to be quite insightful at times. And I think this will be an interesting perspective that he'll bring to our students and faculty today. But just a few words of background information. John got his BS and MS in electrical engineering from Penn State. And he's also done additional graduate work in lens design and optical systems engineering. He started his career at IBM in the optics lab there, but then he moved to the Naval Research Lab, where he worked for a number of years on developing hyperspectral imaging systems for airborne national defense and oceanographic remote sensing. And then in 1999, he founded Brandywine Photonics, still in business after 25 years. I guess you have an anniversary coming up here. And the highlights being the spectrograph for the HICO instrument, which flew on this space station, and instruments for the WeatherSat program. And his current professional interests include small weather satellites, which I think is what he's going to focus on today, artificial intelligence and machine learning for spacecraft computers, electro-optical and infrared payload manufacturing, and custom focal plane array technologies. And so we've had the pleasure of hosting him since yesterday afternoon, and he's gone around and met a number of folks and seen a number of labs here, and he's commented that there's quite potential here for our group and our activities. So with that, let's welcome John and get started.
Thank you very much, Dr. Caracas. This is the first opportunity to roll out a new brand. So WexNet, you'll see it was called NetNet, but Google had the same time I did in my 2018 paper. So I don't want to compete against them. And then I tried Pantheon, and now I think you'll see why I'm calling it WexNet here shortly. So and with that, I will proceed. Once again, Airborne Science, that's my LinkedIn profile. So feel free to connect with me. What inspired me? I was when I was growing up in the 1970s, I would watch the Undersea World of Jacques Cousteau. I mean, even the reruns, I was all over that. And then, Carl Sagan came out with the original Cosmos series, and it really lit my fire as a young adult, as a child. And but when I went to electrical engineering school, that sort of programming and the Commodore 64 and tape drives were what sort of took over for a while. So here are my heroes: Jacques Cousteau, Carl Sagan, and if you know the person on the right, I will congratulate you. I'll talk about him a little later. Harry Wechsler, one of the two fathers of satellite meteorology. So remember that name, Harry Wexler. So my career was a crooked path, both from going from academia, Penn State, to IBM, and wanting to learn lens design. Went to URS Alabama Huntsville, studied under Barry Johnson and Russell Chipman. Learned a lot about lens design, but I basically flunked out of the graduate program because I didn't was spending all my time designing lenses and none learning semiconductor physics. Went back to IBM, and then, during the Great Purge of 1993, where they laid off 300,000 people, I sent out 150 resumes, and number 130 landed me at the U.S. Naval Research Laboratory. So the job market is much better for you now. Don't worry. You'll get picked up before you even if you don't even do a resume. And then but it wasn't enough. I wanted to create my own research, but I didn't have a PhD. So what do? You start your own company. So I was foolish enough, hung out a shingle, went back to my hometown. As I was telling some of the students earlier, decide where you want to live and like where you want to live because you may be there for a while. I built my first spectrometer in my spare bedroom. And after that, slowly built up the business and have had my ups and downs. But in some ways, I got to go back to my original loves 15 years later, which is a little bit of oceanography, weather remote sensing, and a little bit of innovation. I've gone from hyperspectral imaging back to weather, then back to hyperspectral. So don't worry if it's a crooked path you take in your careers. Somehow it gets guided back. We built a little bit of Brandywine, what we do, highly technical. I like how RIT is building their program where I do a little bit of optics, a little program management. I've developed did all the lens designs for all of our instruments, and now I'm guiding lens designers now for imaging spectrometers, interferometers, all the 13 different ways of hyperspectral imaging, of which you may only know 2 or 3. So really exciting stuff. Have all these instruments worked? Sadly, no. We've had failures. Out of the 9 focal plane programs, 3 never worked, 3 needed fixing, and 3 really went well. So it's a crooked path. And make sure if you start your own business, understand contracts and people. So we've a wide variety of airborne systems. And some of the data you can see here is the HICO instrument. One of the first instruments I built in my spare bedroom for the airborne Cassie, and then built the HICO instrument in the clean room, the spectrometer. And for the Picard instrument, which flew on Pace this past summer, we built the whole thing soup to nuts. So quite a challenging job, but and worked closely with NASA Ames on some of the repair work on the calibration and the second order filter. So it doesn't always go smoothly with the instruments you build, but when you have a great partnership with your customer and good contracts, it brings it to a valuable fruition. Bringing up to the present day, we build hardware. And one example of this is an infrared camera. Has a variety of utility, including wildfire. And for this instrument, it's mid-wave infrared, large format. I designed all the optics while I was managing the company, and we hired a new engineer, Matt Kimmick, who leads our cryogenics group in Utica, New York. So we are a diversified company, and that was one of the challenges we've had in our company is how do you do remote workers, especially when you're dealing with hardware. From a prior project, we found out the electronics we got from the government didn't work. So we just dove in and built our own camera electronics. It required calling in some favors, some old friends from Naval Research Labs who were great FPGA programmers. And we built the electronics, we space qualified it. We built our own TVAC chamber, own lens assembly station, all through COVID. It was a good time actually because the building was empty, so we could build our own clean room and lens alignment station. So really exciting hardware, but once again, nothing comes without hardship. It requires a high level of resilience to walk into the work in the morning and get a call from a customer and say everything broke in shipping, and your just gut falls to the lower intestines, and you're just like. So it requires a huge amount of I won't say grit. Grit is how it gets you through the final exams. It's more resilience and saying, I own that. I own that mistake. Not my employees, although they have contributed, but as a team, we own it. We're going to make it right. But then there's great successes, which you hear about 5 years later that the scientists have been using your data for 5 years and it's been published, and they never told you it's getting published. So it's, but there's an internal satisfaction there. Now we're wide a variety of payloads. We do the soups to nuts. So package design, specifying and working with focal plane manufacturers, building the integrated detector core assemblies, building the electronics, assembling the lenses we design, and even larger aperture telescopes, 300 millimeter aperture. And we're working toward 50 centimeter aperture for high signal to noise ratio hyperspectral imaging. If you hear about people that are launching 2 centimeter aperture hyperspectral imaging imagers into space on a CubeSat, I would recommend not buying stock in their company. Well, once again, we always take that next step. That's the advantage of being an entrepreneur and not being constrained. So I love proposal writing. My half page an hour is what is the whip I put on myself. And so we developed essentially your own space computer designed on the Vita 90 or / Sensors Open System Architecture standard. You'll have a GPU, CPU, and memory modules, and we're looking at the next step being a AMD Ultra Scale Plus FPGA, along with a RISC-V CPU. So very exciting to get that and getting into the AI/ML, as well as encryption is a key, and that's going to be it takes a long road to get there, to get to zero trust post quantum computing security. So we built this box and we wrote a proposal, got funding from the Army, and hopefully it will be flying on a drone next year. And then once again, it's a small company. We build our stuff. So we build our own TVAC chamber, clean room, lens assembly station, work with labs here, getting our calibration set up, all the characterization for a 15 micron wavelength infrared sounder. And in this, we had to get AS9100 certified, which is similar to ISO 9001, and cybersecurity, NIST 800-171. So it's, I'll, by the way, give you a sense of our team. We go from anywhere from 6 to 12 people. So it's, I think we're on drink and jolt every day. It's high intensity. It's much like a much like a PhD program, right when you're about to, try to get your thesis done and, get data to do your thesis. But we have a great team, but it's not for everyone. I've had to fire people and lay people off. It's not pleasant. Some have gone because they just weren't cut out for the diversity. There's people there that people just like one thing and one thing alone, and they don't like life changing every week. Whereas in a small business, you never know what's coming through the door next. That's like the gladiator, saying. It could be something as simple as a broken cable on a HDMI that makes you miss your deadline. Or it could be a detector that wire bond fails after the third attempt. Or it could work, and you're like, wow, the point spread function is greater than 60%. Optics aren't supposed to be that good because the focal plane actually curved the way you want it or didn't curve the way you want it. I never thought of checking focal plane flatness as a requirement that I send to the manufacturer, but these little details make a difference. So that's and one last thing for all the tech geeks, we're taking simulation and modeling one step further with I'll call photons in the loop or hardware in the loop testing. RIT does a great job of digital simulations, but what if you could actually inject photons into the system? So that way an operator, managing a payload wouldn't know if is it on orbit or is it in the lab next door? Real payloads, full end-to-end system modeling, because you don't really know. Modeling is like playing video games. If you do it long enough, you start to believe it's the real thing. So until you get it out into the lab or get it out in the field, but there's that gap between digital simulation, and having it in the field. Well, it takes you 2 to 3 years to get it on orbit. What do you do with the engineering development unit in between? So we built this infrared test range with some partners where we could test hardware in the loop, real photons going into real flight hardware, and then simulate all sorts of targets and backgrounds. So getting back to Harry Wechsler, one of his quotes with him and John Bellamy, he defined meteorology. Getting back to the science folks, moving away from technology hardware to science again. His quote is, the goal of meteorology is to portray all things atmosphere, everywhere, always. Well, that's a nice saying. He couldn't do that in 1960. We have the technology today to do it in 2024. But it's, like I said, it's a nice thing. Can we go one step further? Let's call this WexNet after Harry Wechsler, and as well as WX is a short abbreviation in the DoD for weather. So WexNet mission is to observe all things Earth, everywhere, all the time, for our families and generations to come. If you take that in, it's kind of crazy. Considering now the satellites they're building are $1 billion. How are you ever going to have enough satellites to actually achieve this mission? Because there's a lot to do in particular weather data, but also extends to land and oceanographic. You need advanced measurements, air quality and ocean altimetry, upper atmosphere dynamics, resiliency. What happens when a rocket launch fails or a cryocooler heat pipe fails? How about the poles? To have 24/7 observation over the poles to see what's going on in the Arctic as it responds to climate change. Revisit time. Firefighters care. They don't want to wait 6 hours for the next set of data. That's literally can be a lifetime. And the resiliency, especially with the U.S. National security, if there were to be a conflict, the United States could lose GPS and could lose our weather satellites. If it, take a breath, think about that. We could lose because we are space is contested. So the challenge with WexNet is how do you solve that? Like I said, there's a world of unmet observations out there. NASA's and the DoD's current approach is take the top 2 or 3 priorities and say we don't have the budgets for the rest. For me, that's unacceptable as a taxpayer when it could be solved. All the way from imaging to fire mapping, upper atmospheric dynamics, to vegetation LiDAR, seeing how our world is changing, in Brazil and rainforests, to hyperspectral mapping of the oceans, with harmful algal blooms. Our society, the world is changing, our climate is changing, our world is responding, and our geography, Florida's tons of people are moving, many people are moving to Florida in the worst possible place for climate effects of global climate change. And we have all these unmet observations. So what's the challenge? The challenge is fighting the legacy flagship satellite approach. We now have launch costs for a 300 kilogram satellite is $2 million to $3 million. Before it was $500 million, a couple $100 million, and you couldn't afford, you didn't want to put a cheap satellite or affordable satellite. You wanted the best satellite there was. Now with launch cost $2 million, satellite costs, you can get out your credit card and order a satellite, 50 kilogram payload, for $1.75 million. Lower cost than some of the houses probably on the hill on the river. Payload costs are now we're quoting $10 to $15 million for solid 30 centimeter aperture hyperspectral imager, SBIR, whether for methane or mapping. But the problem is, let me just check time here, 3:22. Okay, I'm doing fine. The problem in space news, when I see quotes like this, I don't think any of us expected that everything would get done on time and within budget. Imagine that. And this is the chair of the Earth, co-chair of the Earth Science Decadal Survey, which is what guides our nation's Earth observing systems. And how many did they launch in 2007? 1 out of 15. What grade would you get if you got one answer correct out of 15? So something needs to be done. So what's been done in the last 10 years? Complaining about budgets. They've restructured, advanced the budget. If you had a project and, you're building, let's say, an instrument for a drone, would you go back to your professor and say, I need another $5,000? I don't think it would go over well. But that's what's happening to our intransient system. So there's an opportunity for this next generation to change that, whether through building your own companies or to work with startups in Silicon Valley or other, or even create a startup here in Rochester in Earth Science. So once again, we're talking about what's the problem. It's this flagship mentality. Throw over the proposal, send an RFQ, support a 20, 30 team science, 50-person science team, but you never launch data. Innovation is not about, publications. Innovation is not about Series A or having an accelerator program for startups. Innovation is one thing and one thing alone, launching Earth observation capability or in orbit. You've heard a lot about CubeSats. Sorry, I hate to tell you, but you can't get the thermal and the communications and the lifetime from a CubeSat, especially for SWIR hyperspectral. There's some niche cases on, high frequency microwave sounding, and then they're great training for system engineering. So from an educational purpose, yeah, it's a great place to cut your teeth. But simply, there's a lot of system engineering, and the system engineering for a CubeSat can be just as hard as it is for 230 kilogram satellite. Thinking about going on a 3-week vacation in Europe and being able to take only a handbag. There's just not the capacity on CubeSats. So you won't see any NASA CubeSat happy dances from me. Where is it going? The 300 kilogram SBIR class, $2 to $3 million for launch, plus cost from $2 million to $8 million nominal, $15 million with a lot of customization, and more of a system engineering approach, where the application scientist is talking to the focal plane expert, who's talking about the cost and schedule and meeting and budgets, who's talking about orbital mechanics, who's talking to the data system architecture and AI person, and having this trace space throughout the design process. And then you have preliminary design review, critical design review, lock it down, launch in 2 years. So this is where the world is changing with Earth remote sensing. So our proposed WEXNet is around 125 satellites, all SBIR class, all connected over Starlink or the Space Development Agency's optical network, and enabling other hosted payloads like space weather, reflectometry, low light level, some light level, light payloads for hosting, and to observe all things Earth, everywhere, all the time. And to give you a quick view of what that would look like, here's a 15-minute revisit, some orbital analysis, 24 satellites, each with a 1,500 to 2,000 kilometer swath, altitude around 832 kilometers up to 1,000 kilometers. And the yellow is less than 15-minute revisit, and the blue and the black is greater than 1 hour. So for most of the globe, most of the time, you're able to do all things Earth, everywhere, all the time, at the 1 to 2 kilometer resolution. For the finer resolution, so this is weather. For the finer resolution, obviously you're going to need some, pointing systems. So you'll still be able to get that 1 to 2 hour, but it will be in a, so say a 30 kilometers, 60 kilometer chips of a coastline. So this is for weather, high resolution, hyperspectral. Still, you need swath width and higher coverage. So you're more like a day to get all things Earth everywhere all the time. And more advanced is the sensor web, where autonomous systems are connected to the satellites. So if you think about it, let's say a commercial weather satellite detects a fire sub-pixel using some advanced algorithms. That sends automatically a request, a task to a high-resolution satellite, which then tasks other satellites to look at air quality and winds, sends that data both to a near real-time satellite, and as well as obviously the firefighters and fire controls, gives warning, which then directs a drone. So these sensor webs have been talked about for a while, but it's just now getting to a point where you can incorporate AI ML edge processing. You can incorporate drones, direct-to-drone communications, put your Starlink terminal on your drone. So all the parts here could be full mission, $50 million. For the satellites, the drone ground segment could be, $100,000. But the challenge is, the labor, obviously, and the software coding and the engineering support to do these full systems compared to the cost of extreme weather is to our nation's economic prosperity, whether, latest, hurricane, wildfires, the amount of damage that's being done, and to save lives and property. That's the mission of NOAA. This is not happening right now, but it's up to folks like yourself to make it happen. So it's your mission now. Your professors and myself, we're aging out. We're not going to see 120. I'm unlikely not to see 120 satellites, or at least be a part of it. This is your mission now. It's your Earth. It's going to be your children. So I give this to you. Take up the mantle if this is where you want to go in your careers. To be a part of something where we observe all things Earth, everywhere, all the time. So I'd like to thank you and have questions. And if I don't have questions, I have a song after this. So you don't want me to sing.
Great, thank you, John. Questions? I know I have a few, but
yes, in fact.
So with the CubeSats, is it, do you think it's never possible question or problem, or do you think it's a currently impossible? So because you talk about innovation, right? So do you think we'll get to a stage where we'll be launching full-scale spectrometers on CubeSats, or is that just never going to be possible given the physics involved?
Much like I said, could you go to Europe with a handbag and everything in your handbag? The answer is yes. Would you like it? No. So they're just really simple. It's a matter of physics. How do you dump, 40 watts from the cryocooler, let's say, or 60 watts from 2 cryocoolers with a, 60-kilometer swath? How do you get the aperture? It's very hard to fit a 50-centimeter aperture on a CubeSat. Yes, you could have a CubeSat and bolt that CubeSat to the telescope, but then, and why bother? If you can get a pickup truck the same price as a scooter, you go for the pickup truck, right? So the cost, when you add in the system engineering, that's the thing that people forget about. They forget about the engineering labor it takes to make sure that what you put on orbit is calibrated and has this, isn't going to turn into a brick. Yes, in the back.
Connecting with Starlink and things like that. Is security an issue for that one? Because everything is kind of connecting, you're sharing data. How do you kind of tackle things like that?
Yes, there's, if anyone wants to start a company, there's only one company that's making NSA Type 2 encryption radios. It's called InnoFlight. So they're pretty much have the market. If anyone has, and it takes 2 to 3 years at least to get the NSA approval. So it's if you're in the encryption market, just make sure you retire by, you'll be able to retire by the time you're 35. Yes.
So I know with like some like remote sensing modalities, like let's say with radar, you have sort of bandwidth restrict, like bandwidth overlap. Like you can fly certain types of SAR over the US. So with I imagine with that many satellites, like wouldn't you run into like sort of bandwidth overlaps or things like that, like where you yeah, isn't that a concern? Because you said 24 microwave, and then I think there was radar too.
I mean, the microwave, you do have to get your FAA approvals for a remote sensing license. And then there's RTARS restrictions. I think for hyperspectral, it's 30-meter GSD. But there's a big push, Evan, if you watch space news. The commercialization of space is happening. Whether NOAA, NASA, and the DoD likes it or not. Because, it's, so there'll be, even last month, there was a loosening of ITARs with space related technologies. So so there are concerns, and it's not going to be fully open, but all just regulation paperwork.
So I have a question. It's very intriguing to have this constellation of satellites. And so right now, the US and in partnership with other countries has a handful of satellites that collect similar but not the same kind of data. And I'm just wondering from a weather monitoring and weather prediction perspective, what kind of, if any, advantages would come from this constellation of so many satellites? Have you thought about that?
So it's primarily revisit time. No one likes getting, stale bread, right?
Yeah.
And weather data goes faster, goes stale faster than fish on a hot afternoon.
So some of the advanced geostationary instruments can image every few minutes or even 1 minute.
15 minutes is for geo, for GOES.
Well, it can do the whole globe or the whole disk in that, but it can do finer areas smaller as needed. And so what advantages would this system have over, a constellation of geo satellites?
Good question. Geo's far away. Leo's closer. So you're able to get infrared sounding is easier from Leo, lower cost. If talking GeoXO, they're looking at $20 billion now for GeoXO, launch in the 2030s.
Say that again. How much?
20 billion with
20
a B.
Billion.
20 billion with a B. And as I say in my song, actually, could be 15 billion. It's going up. And it's a cost plus fixed fee. So in other words, if they overrun, they'll just keep on getting money. So $2 to $3 billion is spent globally, not including China, on weather satellites. You cannot, at the present day, do microwave sounding from GEO. And the infrared sounder, they could only afford one, and that's over the central US for GeoXO. Well, that's not where the hurricanes are forming. The hurricanes are not forming over Kansas. So there's inherent budget limitations with the GEOs. I may walk this back when I just know of a new company starting out. They're doing a GEO satellite designed for Starship. So it's able to handle like 10 tons of payload. And its cost is $50 million for the bus.
Question. So sort of a follow-up to that. So it seems like there might be a good cost and system optimization and resilience advantage to kind of shifting from these large flagship programs to a more distributed, smaller, cheaper individual satellites in a constellation. What will it take to have that tectonic shift occur?
I hate to say it, but it would take a radical president of the United States that's willing to break things. Unfortunately, we have that today. That's one perspective. The other is for everyone to retire from NASA Goddard in the next 5 years and be replaced by energetic new ideas like that come from the people in this room.
There's your charge.
Pure Earth.
Do you want to?
Okay, well,
song here.
Okay, we'll lead. Okay, you guys do the refrain. It's another climate change headline day, fires, floods, and hail. But the weatherman can't say, is my street safe or should I bail? The spotty weather satellite data didn't make the news. I feel it coming along again. We've got the weather data blues. A $50 billion price tag isn't what Noah says we need, or we are lost. But the GAO says that's low by a factor 2 in cost. The spotty weather satellite data make the news. I feel it coming on again. It's weather data blues. A friend of mine's an Air Force pilot that flew through a squall of ice and snow. No DMS 13 satellite to warn him, as that blew up years ago. The spotty weather satellite data didn't make the news. I feel it coming on again. I've got the weather data blues. We've come up with a solution. We'll gladly pay for it. It's true. The WEXSat constellation at 5 cents per sounding. Who knew? The spotty weather satellite data will no longer be in the news. We can prepare better for climate change and no longer weather data blues. Thank you for doing it. I will no longer be a songwriter. I think it's just career.
It's a #1 hit. It's going to go to the top of Spotify.
Any questions? Feel free to come down, chat. We're here for you.
Very good.
I'll just stop.